All right, so it says consider the functions f and g, and f of x is 1/2 raised to the x plus 1, and g of x is log of x minus 1 plus 1. So it says after 3 successful iterations, figure out what the answer is, okay, or the approximate solution. So what we do is this process is interesting. You're going to take the average. So it looks like it crosses where x equals, it's between 2 and 3, okay? So what we'll do is we're going to start by evaluating this by we got to set them equal to each other first and foremost. So I'm going to say log, because that's what we're really saying is when do these two equal each other, okay? Log of x minus 1 plus 1 should be equal to 1/2 raised to the x plus 1. And then what I need to do is set them both equal to 0. So that's easy. I'm just going to subtract all this stuff on the right-hand side. So I've got log of x minus 1 plus 1 minus 1/2 raised to the x minus another 1 equals 0. Okay? And then from there, I'm going to look to see what my possible answers are. So it looks like we're going to think about x equals 2 and x equals 3. So my answer is between x equals 2 and my x equals 3. Now we call this the lower boundary, and we call this the upper boundary. And so what we're going to do is we're going to come in closer and closer and closer to this boundary to see what makes this equal 0, okay? So now, before I do that, I've noticed that I have a positive 1 here and a negative 1 here. So I can just toss those out, and I'm going to evaluate this at log of x minus 1 minus 1/2 raised to the x equals 0. I'm just simplifying my equation, okay? And then what I want to do is I want to evaluate this at the upper and lower boundaries. So I'm going to just do that with the calculator because it just goes quicker. So I'm gonna graph this equation here. That's the benefit of this, is that if I graph it, the calculator automatically puts in the values for me, okay? So if I come over here and I hit y equals, and I clear this out, I could type in log of x minus 1, close the parentheses, right? Minus 1 divided by 2. Oops, I got to put that in parentheses. What am I thinking? 1 divided by 2, close parentheses, raised to the x. Now what I can do now is I can go to my table set, and I can start at 2, okay? And I'm just going to leave this, I'm going to count by 1. So now when I hit second table, I could see what this is evaluated at, 2 and 3. So this function log, well, let me use a different color so we don't get confused. Log of 2 minus 1 minus 1/2 raised to the 2 is equal to negative 0.25. Okay. And then change the color again. Log of 3 minus 1/2 raised to the 3. So wherever there's an x, I'm going to plug in my lower boundary of 2 and my upper boundary of 3. Okay. And that's evaluated at 0.17 and some change. Okay. So what we have here is one yields a negative result and the other one yields a positive result. Okay. So now what I can do is I could take the upper and lower bounds and average the two. Okay. So if I want to take the average of the upper and lower bounds, what I simply do is I go, okay, well, what's the average? Well, the average is, I'm going to take this 2 and the 3, and I'm going to say 2 plus 3 over 2, which is actually equal to 5 over 2. Okay. Now that what we're doing is we're trying to go, we're going to hone in closer and closer. And then we're going to substitute this value in to the equation because we want to see what it does. Now, we need to see if it replaces it with an upper or lower boundary. So now what I'm going to do is I'm going to say log based 10 of 5/2 minus 1 minus 1/2 raised to the 5/2. Now that's actually 2.5. So now what I'm going to do is I'm going to go into the calculator and see what that yields. So what I need to do is I need to change my increment. So I'm going to go here. I'm going to start at 2 and I'm going to change this to 0.5. And now I'm going to look and see what the values are now. And at 2.5, it's a negative value. Okay. So it's pretty darn close to 0. So our answer is going to be pretty close to 5/2. So, oops, wrong thing. So this value is -7 times 10 to the -4. So this is negative. So it's like negative 0.123. So that's what that is. Now, since it's negative, we're going to replace our lower boundary which is 2. In other words, my answer is probably trapped between 2.5 and 3. Does that make sense? So if this were to be positive, we'd replace the upper boundary. We always want positive solutions when we do this. So now what I'm going to do, the next iteration is I'm going to say 5 over 2 plus 3 and I've got to take the average of that. So really I'm saying 2.5 plus 3. Well, what's in the middle of 2.5? Well, let's just do the math and add it up. So this becomes 6 over 2, right? If I multiply this and multiply this by 2, I get 6 plus 5 over 2, and then I'm going to take 1/2 of that. So I'm going to multiply that by 2. So I get 11/4. Okay. So now this is tricky because 11/4 is actually 2.75 approximately. So now I'm going to come in here on the calculator, and now I'm going to find 2.75. So I've got to take my calculator, and now I've got to evaluate this. And they only want us to go 3 iterations. So we got one more iteration after this. So I'm going to hit table set, and now I'm going to plug this into 0.25. Okay. And then I hit the table. And so now I get this value. So in other words, I said log of 11/4 minus 1 minus 1/2 raised to the 11/4. And now I get, when I come down here, I get a positive value, right? So when I look at 2.75, now I have a positive value. So now I'm going to replace the upper boundary because it's a little too much. So my upper boundary's a little too high. Okay. So now I'm going to take, this is the weird part, I'm going to take my lower boundary, which is, I'm running out of room, 5/2, and I'm going to take the average of that plus the 11.4. So what I'm doing is I'm halving these values. So this will be 2. So then to get that, I got to multiply the top and bottom. So if I multiply this by 2, I get 4. If I multiply this by 2, I get 10. So I get 21/4, and then I got to take 1/2 of that, which is 21/8. So that's the halfway mark between 2.75 and 3. So I'm going to plug in the calculators, and it's so much easier just to graph these, but I'm just going to do this one time. So now I go back to my table set, and 1/2 of this is actually 125. All right. So that's actually 1/8. So if I were to go back, if I go back here and quit, if I say 1 divided by 8, whoops, 1 divided by 8, that's 0.125. Now I've got 21 divided by 8, that gives me 2.625. So that's what we're going to look for on our table of values. Okay. Oh, I forgot to write this one down. So the 2.75, this was 0.09, which was positive. And then we're going to evaluate, we're going to come over here and we're going to evaluate log of 21/8 minus 1 minus 1/2 raised to the 21/8. And now I got to look at that value, which is positive, right? So it's 0.05 roughly. So this is 0.05. So it's positive. So now I've got to replace that, because it's positive again, I've got to replace the upper boundary. So I still have 5/2 plus 21/8, and now I've got to take half of that. So to make this 8, I multiply by 4. To make this 8, I multiply by 4. right? And that gives me 20 over 8. So then that yields 48 over 8. This is the last time we have to do this. And then I take 1/2 of that. So you get 48 over 16. Now to find 1/16, I'm going to take my calculator. Could you imagine if we did all those problems this way? So now I'm going to take my calculator and I'm going to say 48 divided by 16, so I know where to look. It's going to be 2 point something. No, it's not 48 over 16. It can't be. Oh, you know what? Got a typo. It's 21 over 8. Whoops. Whoopsie. So it'd be 41 over 8. Got excited. So anyways, so 16th. So I've got to figure out what my incremental is. Right? So I just say 1 divided by 16. So it's got to be 0.0625 is what I've got to change in here. So let's just do that real quick. So this becomes 0.0625. And then now let's go back and I'm going to say 41 divided by 16. Okay, so that's the number we're looking for, 2.5625. So I'm going to look at this, and this is it right here. Okay, now we can stop there, but the answer is approximately 41. So if we were to stop right here, the approximate value should be 41 over 16. Because we're only doing 3 iterations. And so the calculator repeats this process, but really what we're doing is we have an upper and lower boundary, and then we're tightening the upper and lower boundary based on whether it's positive or negative. If it's negative, we replace the lower boundary. If it's positive, we replace the upper boundary. So after all that math, because we got 41 over 16, the answer is x is approximately 41 over 16. That's it.